Hello student, functional analysis paper number 13 unit 2 first topic matrix space. Let any non-empty set X and a function D from X cross X to R is said to be matrix if the following conditions are satisfied. First condition, distance of 2 points always greater than or equal to 0. D of xy is greater than or equal to 0 and distance is equal to 0. D of xy is equal to 0 if and only if x is equal to y. Second condition, distance of xy is equal to distance of yx. Third conditions, distance of xz is less than or equal to distance of xy plus distance of yz, and the all conditions are satisfied, and then xd is known as a matrix space. Next, non-linear space. Let n be any non-empty set and k be any scalar field. A function norm from n to k is said to be norm on n if these conditions are satisfied. First conditions, norm always greater than or equal to 0 for every x belongs to x, and norm equal to 0 if and only if x is equal to 0. Second condition, norm alpha into x is equal to mod alpha into norm x, where alpha belongs to k and x belongs to x. Third condition, norm x plus y is less than or equal to norm x plus norm y for every xy belongs to x. These conditions are satisfied, and then n norm is called a norm space. Cauchy sequence. Let given sequence xn be a sequence in X, then there exists n0 belongs to n. There exists n0 belongs to n such that distance of 2 points xn and xm is less than positive number epsilon. For every epsilon greater than 0 and for every nm is greater than or equal to n0, then it is Cauchy sequence. Banach space. Banach space. A complete non-linear space is called Banach space. Banach algebra. Let A be a non-empty set and A is linear space over a scalar field K, and if multiplication is defined on A with the following property, then it is called Banach algebra. Property first, xy in the bracket xy into z is equal to x into bracket yz for every xyz belongs to A. This is associative law. Second, x plus y in the bracket into z is equal to x into z plus y into z, and x into in the bracket y plus z is equal to x into y plus x into z. This is distributive property. Third, alpha into in the bracket xy is equal to in the bracket alpha into x into y is equal to x into alpha y for every xy belongs to A and for every alpha belongs to K. In this definition, A is non-empty and A is linear space over scalar field K, and the multiplication defined on A with with this property satisfied, then it is called Banach algebra. If multiplication is commutative, then it is called commutative Banach algebra. If there exists a non-zero element 1 belongs to A such that 1 into x is equal to x into 1 is equal to x, then for every x belongs to A, for every x belongs to A, then A is called algebra with unit element. Not unit element in A is unique. Let we consider two unit element 1 and 1 dash. By definition of unit element, we can write 1 is equal to 1 into 1 dash plus 1 dash into 1. Equation number 1. And by definition of unit element, here we consider unit element is 1. So 1 dash is equal to 1 into 1 dash is equal to 1 dash into 1. Equation number 2. From the equation 1 and 2, both are equal. So unit element is unique. Not. If field is real, then A is called real algebra. If field is complex, then A is called complex algebra. Example, script C of X are defined as the set of all the continuous function from X to R. Script C in the bracket of X into C defined as the set of all the continuous function from X to C. They both are commutative algebra with unity. Next, let X is non-empty and f is the set of all real valued function defined on X, then this is pointwise addition f1 plus f2 of x is equal to f1 of x plus f2 of x. This is pointwise scalar multiplication alpha into f of x is equal to alpha f of x, and this is pointwise multiplication f1 into f2 of x is equal to f1 of x into f2 of x. F is an algebra. F from x to R, 1 of x is equal to 1 for every x belongs to x. Definition: subalgebra. A subset of an algebra A is said to be subalgebra of A if it is an algebra with same operator, same operations, addition, scalar multiplication and multiplication. Thank you.